Good morning, my dear students. See, part 2 of mathematical reasoning. So first I'm going to discuss one definition which is called logical equivalent. So when we say that two statements are equal, nothing but equivalent. When two statements are equivalent, that means they are giving same meaning. So when we say that two compound statements are equivalent, if the truth value of both compound statements must be same. Both compound statements must be same in all combinations. Then only we can say that those two compound statements are logically equivalent. For example, if capital A and capital B are two compound statements, so if they are logically equivalent and it is denoted by the compound statement capital A logically equivalent to the compound statement capital B. Okay. Next, before going to discuss some properties, so just there is some relation between this mathematical reasoning to sets. So in sets, union is just like OR in mathematical reasoning. So there, whatever the properties are holes on union, the same properties are holes in OR. Okay, in set theory, union; in mathematical reasoning, OR. Similarly, intersection, AND. So in case of union, commutative property holds. So A union B is equal to B union A. Just like PRQ is same as QRQ. A intersection B is same as B intersection A. So in same as P and Q is same as Q and P. Next, we know that complement. A complement, whole complement is nothing but what? A. Here also, negation of negation P is what? P. And in sets, universal set is just like tautology in mathematical reasoning. So tautology, it is always true, small t. And empty set, here it is same as contradiction, always false. So we know that A union universal set is A. So PRT is same as T. A intersection universal set is A. P and T is equal to P. Next, A union empty set A. PRC is equal to P. A intersection empty set P and C is equal to C. Next, A union A dash universal set PR negation P T. A intersection A dash null set. So here P and negation P is C. So that means if you can remember this, so in set theory union is just like in mathematical reasoning R, and here intersection is just like AND, here complement is just like negation, universal set is just like tautology, empty set is just like a contradiction. No need to by heart all these properties, because we know already those properties in set theory. We learned already in first PUC only, and that first chapter only we learned those properties. Okay, so that means if you can remember this, union is just like R, complement is just like negation. No need to by heart once again all these properties. Okay, so next, negation of the logical negations of the basic compound statements. Okay, so negation of PRQ, we know that De Morgan's law we have learned in set theory. A union B whole dash, A dash intersection B dash. So their universal union is nothing but OR, intersection is nothing but AND, complement is nothing but negation here. Okay, so negation of PRQ is negation P and negation Q. So just you remember, R becomes AND becomes R. Whenever if you apply negation, so here R becomes AND becomes R. So here P, if it is P becomes negation P. Suppose here negation P is there, basically here it will get negation of negation P is nothing but P. So negation of PRQ is negation P and negation Q, nothing but A union B whole dash. Next, second one is nothing but A intersection B whole dash. A intersection B whole dash is what? A dash union B dash. So negation of P and Q is logically equivalent to negation P or negation Q. Next, A dash whole dash A. So negation of negation P is P. And these two you have to by heart, you have to remember. And this one also. this one, so these three you have to by heart. And how to prove these two are logically equivalent? That's why I'm going to prove that. I'm going to solve this last problem only, and remaining also you can prove by drawing truth tables. Okay. So here in P implies Q is equal to negation Q implies negation P. In that, what are the components, basic components P and Q? So first I am writing first two columns P and Q. Next, sorry, here it should be negation of, only P implies Q. Here not required negation of P implies Q. P implies Q is logically equivalent to negation Q implies negation P. So I am going to prove this. Okay. So first in this compound statement, what are the components P and Q? So first two columns P and Q. Next I am calculating truth value of P implies Q. P implies Q. Next in this, what we have to calculate? First truth values of negation P and negation Q. Then we have to calculate the truth value of negation Q implies negation P. Now I am going to show that the truth values of these two compound statements will be same in all combinations, so that we can conclude this P implies Q statement is same as negation Q implies negation P. See, here components P and Q. So there are four combinations: true, 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 false, false, true, and false, false. And it implies, what is the key point? So how to know what is the key point? First component true, second component false, then only false. So first component true, second component false, then only false. Remaining cases true. Next, negation P. So whenever P is true, negation P is false. Whenever P is false, negation P is true. So here, first combination P is a true, so negation P false. Next to P is a true, negation P false. Next to two cases P is false, so negation P must be true. Next, Q, just like say in the same way Q. This is Q, negation Q I have to calculate. So negation Q is what? Negation Q becomes first case false, second case true, third case false, last case true, because here true is there, here we get false, here false is there, here true. Similarly here T, F is there, here F, T. Now negation Q implies negation P. Again here, what is the logical connective? Implies. What is the logical connective? Implies. So what is the basic rule? What is the key point in that? First component false, first component true, second component false, then only false. First component true, second component false, then only false. That means here first component is what? Negation Q. So it should be true, second one should be false, then only false. So in which case we are getting true false? Here only we are getting true false. So true false is what? Negation Q implies negation P. No? So we have to check this is the first and this is the second. So negation Q to negation P. Okay. So first component true, second component false. Then in this case what will get? False. Remaining cases true. So just if you observe, what are the truth values of P implies Q? In first case true, second case false, third case true, fourth case true. And here we are getting the same. So from these two columns, third column and sixth column, from these two columns what we can conclude, these two compound statements are one and only same. That means this compound statement logically equivalent to this compound statement. That is negation, not negation. Therefore P implies Q is logically equivalent to negation Q implies negation P. Okay. So after that, next up, converse, inverse, contrapositive. But in NCERT we have only converse and contrapositive, but better to learn inverse also. If P implies Q is the given conditional statement, remember only for conditional statements only we can find converse, inverse, contrapositive. For other statements we can't find. Okay. So P implies Q is the if given conditional, converse will be reverse. Q implies P. Q implies P. And what is the inverse? Negation of P implies negation of Q. It is the inverse of P implies Q. What is its contrapositive? Negation Q implies negation P. So from the above problem, what we can conclude, given conditional is logically equivalent to contrapositive. It's contrapositive. Negation Q implies negation P. Suppose one example, if I consider one example on converse, inverse, contrapositive, I'm taking a simple example. Okay. So P is the statement. Okay, directly I take P implies Q is the given statement, given conditional. If X is odd, then X square is odd. X square is also odd, or we can write simply X square is odd. Okay, here if then is there, that means it is a conditional statement. In that, what are the components? X is odd, first component P, and X square is odd, this is the second component Q. Then what is its converse? So Q, this is P, this is Q. So what we have to find? Converse. Converse means just make it reverse. So that means if X square is odd, then X is odd. This is converse. This is converse. Then what is the inverse? Keep the same statement. So here negation P implies negation Q. What is the inverse? Negation P implies negation Q. That means P and Q components will be same place only, but we have to negate those components. Okay. So that means if this component we have to keep as it is, but we have to negate that component. So if X is not odd, then X square is not odd. This is the inverse. This is inverse. Next, contrapositive. Contrapositive. So what is the contrapositive? Negation Q implies negation P. Negation Q implies negation P. That means what we have to write contrapositive? If X square is not odd, then X is not odd. So this is the converse, inverse, contrapositive. In JEE mains also, in one of the mains problem, if you observe, from mathematical reasoning, they are asking just contrapositive of the given statement, converse of the given statement also, and inverse of the given statement. And in one of the previous mains I have observed long back, they are asking what is the converse of inverse. Converse of inverse. So here we are finding what converse, inverse and contrapositive of P plus Q. If they ask converse of inverse, what is the left? Contrapositive. Just you find contrapositive of the given conditional. Suppose if they ask converse of contrapositive, what is the left? Inverse. Just you find inverse of given conditional. Suppose if they ask what is the inverse of contrapositive of given conditional, what is the left? Converse. So just you find converse of given conditional. Suppose for this problem only, this given conditional only, find the converse of contrapositive of this conditional statement. So converse of contrapositive, what is the left? Inverse. Just you find inverse. What is its inverse? If X is not odd, then X square is not odd. Okay. So this is about converse, inverse and contrapositive. And next quantifiers. Quantifiers. So what are the quantifiers? For all. This is the for all symbol. And this is there exist. This is there exist. And how to find negation of a statement which contains these quantifiers? So I am going to give my own example. So for all X belongs to yes, X is an integer. For all X belongs to yes, X is an integer. That means what is the statement says? That set S contains only integers. Now I want to give its negation. So what will be its negation? For all X does not belong to S, X is not an integer. It is clearly wrong. It is clearly wrong. Okay. So I will give one more example also. Okay. So suppose you consider a class. Okay. A class. I am selecting a student. Okay, that student instead of that student I am giving some symbol, say X. So if X belongs to that symbol, that class, then X is a girl. That means that class contains completely all girls. Okay, so that completely class contains all girls. Okay, then what is its negation? Means you can't say that all are boys in that class. All are boys in that class is clearly wrong. What is the negation? Means there is at least one student in that class who is not a girl. That means boy. Suppose all girls in that class, all are girls. What is its negation? There exists at least one student in that class who is not a girl, nothing but a boy. Okay. So for example, for this, for all x belongs to yes, x is not an integer. For this, negation becomes what? There exist x belongs to yes such that x is not an integer. X is not an integer. Okay. They can use for all or for every also, no problem. So for all x belongs to yes, x is an integer means. So what is its negation? There exists x belongs to yes such that x is not an integer. And similarly, one more example. There exists x belongs to yes such that x is divisible by 5. What is its negation? So first understand the meaning. There exists x belongs to yes such that x is divisible by 5 means the set yes contains at least one element which is divisible by 5. For this negation becomes what? There does not exist x belongs to yes such that x is divisible by 5. This is as it is, but here instead of there exists, what you have to write? There does not exist. So just here in this place, what you have to write? Does not. Just you write here does not. Then this statement becomes negation of the given statement. So if the statement is there exists x belongs to yes such that x is divisible by 5, then what is its negation? There does not exist x belongs to yes such that x is divisible by 5. Thank you.